In this tutorial I'm going to show you how to make this. We have a rectangle and we can move it with our mouse, and if we click a button we have a bullet coming from our main character. And that's basically it. It's not particularly fancy, but it does implement a basic bullet mechanic, which it can turn into a much more sophisticated mechanic. And yeah, that's basically it. Let's jump right in. And let's start by talking about the logic of how we are going to do all of this. And it's actually surprisingly simple. All we need is to get the position of our main character, and from that position we create a new rectangle and move it to the right. And in our case, our bullets can only go to the right. However, with just a bit more code, you could basically set any direction that you want. And more specifically in code, there are two broad ways to achieve all of this. You could rely on rectangles and do it all with that. And I'm going to show you at the end of this tutorial how to do that. However, using rectangles is very inefficient for bullets. Instead, what you want to do is use sprites, because sprites make it much easier to handle all the different bullets and work with them in different ways. So I will primarily work on sprites. And if you're new to Pygame, check out these two videos. They explain the basics of Pygame and also how to use sprites. And if you want to understand this video fully, I would really recommend to check both of those out. But with that being said, let's get into the specific logic of our game. And here's how I organized all of this. I have two sprites. One is the player sprite and one is a bullet sprite. And the player sprite is actually quite simple. We start by creating a basic sprite in the usual way, and then in the update method, we just get the mouse position and position this sprite wherever the mouse happens to be. But our player sprite also has another method, and I called this one create bullet. And what this one does is that it creates a new sprite inside of our player sprite. Which brings us then to the second sprite, and that's the bullet. And the bullet is actually super simple. It effectively only does two things. One is that it continuously moves to the right, and two is that it destroys itself once it gets too far to the right. And I'm going to explain later on why that becomes important. But that is really all you need to create a basic bullet. So with all of that one done, let's get into our actual code and let's work from there. So here I have some basic code that already covers quite a few things. We start by having our player class that inherits from sprite. So this is our main sprite, and all it does is it creates a surface, it fills the surface, and then it places this surface in the middle of the screen. Then we have our basic game variables. Then we create our player object, we create the group, and then we put the player inside of the player group. And then inside of our game loop, we draw all of this. So if I run this code, all we see is a plain white rectangle in the middle of a black screen. So let's start with the first step, and is that our player follows the mouse, which is one of the easier parts to do, because all we need is in our player sprite, we need to define the update method, and it needs self as usual. And all we need in here is self.rect.center is pygame.mouse.get pos. So all we do here is we get the position of our mouse and we put the center of our rectangle wherever that position of the mouse happens to be. And right now this would not be working because we're not calling the update method. But we can do that very easily via the group. All we need is player group.update, and now this should be working. So let's try this. And yeah, here we go. Now our rectangle is following the mouse. And basically what happens here, when we call the update method on the player group, every single sprite inside of that group that has the update method, like our player sprite, will have this method executed from the player group. So we could have 50 different players inside of our player group. If we call update on the player group, they will all execute the update method. So that's a good start. And there's one more thing I would like to do, and that is to hide the mouse. Because when we run this and we can see the mouse, it looks kind of weird. But we can hide our mouse very easily. All we need is pygame.mouse.set visible, and this one needs to be false. So if I run this now we can't see the mouse anymore, and we can only see our rectangle. This one already starts to look much better. Okay, so now we have our rectangle. Now we need to give it the ability to shoot bullets. And to shoot bullets, we first need to create bullets in the first place. So I will create a new class that I call bullet. And same with the player, it inherits from pygame.sprite.sprite. And let me just copy a couple of things because this is a bit writing intensive. So far this class works basically like our player. We create a new surface, except in this case it is going to be a little bit smaller because a bullet shouldn't be too large. I make it 50 pixels wide and 10 pixels high. And for the color, I'm just gonna fill it with red. So 255, 0 and 0. And when we create the rectangle, we start to see our first difference. So self.rect equals self.image.getRect. This one is like the player. However, now we want the center of this bullet to be where the player happens to be. And to achieve that, we need to give it 2 arguments. And I'm just gonna call them position X and position Y. So when we create this bullet, we can pass in 2 arguments that give it its position. And this is gonna be the position of where the player happens to be at that moment in time. So when we put the center of the rectangle, we are going to put it at position X and position Y. And that's the basic things we need for our bullet. Now we need to define the update method. So update self. And all we need for this one is self.rect.x plus equals 5, or whatever bullet speed you want to have. So all the bullet can do is whenever you update it, it moves to the right 5 pixels on every single frame. So now we have the ability to create bullets. However, before we can put them on the screen, we have to put them into a group. So further down in the code, I'm going to create a group that I'm going to call bullet group. And just like with the player group, this is pygame.sprite.group. And for now, we're not going to add anything. However, when we go up, now we can create in our player character class a new method that I'm going to call create bullet. And it's self as usual. And basically what I want to do in this class is that whenever this method is executed, it returns a new bullet sprite. And then this bullet sprite, we're later going to capture inside of this bullet class. So all we need to do is return something. And what we return is going to be bullet that we create. And the arguments we pass in is going to be the position X and position Y, which in our case would just be the mouse position that we created up here. So all we need to do is pygame.mouse.getPos, and we just need the X part of it, so it's going to be 0. And then we have to do this entire thing again for the Y part, so this is going to be 1. So whenever we call this method, it's going to return a bullet, and this bullet is going to have the position of wherever our mouse happens to be, which is the exact same position where our player happens to be, thus giving the illusion that our player has shot the bullet. But by itself, these are 2 separate sprites. And with that one, we're almost done. The one thing left to do is to give us an ability to execute this method, which I want to do when we press the mouse button. So in our game loop, when we check for the events, I'm gonna check if event.type equals pygame.mouse button down. So whenever we press a mouse button, we want player.create bullet. So this would only create a bullet, but we have to add this bullet to this bullet group. So what we need to do is bullet group.add, and now we have to put it inside there. And that is the basic logic for a bullet. So if I run this now, we can still move around. And if I press a button, nothing is going to happen. And the reason for that is quite simple. I didn't draw any of the bullets or updated them. So what we need is bullet group.draw.screen and bullet group.update. And if I run this now, this should be working, and here we go. The bullets are fairly slow, but you can adjust this yourself. And there's a couple of small things we can add. The first thing is that the bullet starts on top of the player, which is the easiest part to fix. And all we need to do is right now the player group and the bullet group come after each other. And Pygame draws them one after another. So all we need to do to draw the player on top of the bullets is to move this line down. And now this should be working. And now the bullets appear behind our white rectangle, which tends to look a bit better. And here's actually a good lesson that might be helpful. Right now, our game runs at 30 frames per second. And let me increase this massively to, let's say, 120. Now, all our animations are going to run quite a bit faster. So the bullets run much faster because they're going to be called much more often. When we have a frame rate of 30 frames per second, we are adding this one 30 times per second. However, if our frame rate is 120 times per second, we are adding this one 4 times as often, so our bullet is going to be faster. And this is why it really matters to have a consistent frame rate, because if this one was wobbling around, the bullets might go at different speeds, which would be hugely confusing. Now we have our basic bullet. There is one thing that you do want to be aware of. Let me run the code again. We can basically shoot bullets as often as we want. However, these bullets don't disappear. And if you keep on clicking, there will be more and more bullets, which at some point is going to slow down your game quite a bit. And in our case, our game is so simple that it doesn't matter. However, if you have more complex games, this would break your game eventually and make it unplayable. So what we have to do is that once our bullets gets too far to the right, then they destroy themselves. And this is where sprites become incredibly useful. Because all we need to do is in the update method for the bullet, that if self.rect.x is greater equal than, let's say, 1000, or actually is greater equal than screen width plus 200, so it's slightly outside of the screen, then self.kill. And all that we're doing here is that if the X position of this rectangle gets too far to the right, it destroys itself, so that we don't have to keep on drawing it. And if that's the case, we don't end up with a few hundreds or even thousands of bullets at the end, which makes our game much more efficient. But if I run this is going to look exactly the same and you should not be noticing a difference. But just to illustrate it, let's add this to a fairly small range. Let's do this minus 200. So our bullets should disappear in the middle of the screen. So if I shoot them, they are disappearing fairly early, so that you know they are disappearing. So let's move this back to how it used to be. And that is a basic logic for creating bullets. I hope that was helpful. And just for the sake of completing all of this, you can create this entire logic with rectangles purely. You don't necessarily need sprites. However, it is going to be quite a bit more logic and it is going to be much less manageable. And here's the code to achieve all of this by just using functions and rectangles. I achieved all of this by creating one function I called shoot, and it takes one argument bullets, which is a list. And inside of this function, we create a bullet, then we move the bullet, and we also destroy the bullet. And basically what happens is when I go down, we have a variable called bullet ready and bullet group. And the main rect is our main character that we control. And inside of our game loop, we first use the mouse position or mouse motion to place this main rectangle on the screen. So it works in the same way as before, that the rectangle follows our mouse. When we press the mouse button down though, bullet ready is going to be true. And what bullet ready does inside of here is if bullet ready is true, then we append a new bullet to our bullet list. And once that's done, we put it back to false. And in our game loop, this is the really important part. We have our bullet group that contains all the bullets. And we have our function called shoot, and into this function we pass in the bullet group. And basically what this function does is it takes a list of rectangles that represent a bullet, and it moves each bullet inside of that list a little bit further to the right on each frame, which happens in this line here. So we go through all the bullets in the bullet list, we move each bullet to the right by 5 pixels, then we draw all the bullets. And at the end of this, we return the new bullet list. So all the bullets in the new position, plus whatever new bullets we have created. And then to destroy the bullets, we use enumerate to cycle through all the bullets. And if any of the bullets gets too far to the right, we take the index created from this enumerate and destroy whatever bullet has gone too far to the right. And if I run all of this, this does work just as before. So functionally there's no difference. However, when you actually work with them and implement pictures, using the sprites is going to be much better than using the functional approach. And I can actually demonstrate this. So let's add pictures to both of them. And in both approaches you write just about the same amount. But for the sprites, you have a much better idea on where the pictures go and what they belong to. Whereas in the functional approach, it's all very much scattered around the code and kind of annoying to work with and to see what you're doing in your code. So let's do this right now. So here I have both examples of my code open. On the left side, we have the sprite approach. On the right side, we have the functional approach. And let's start adding images to the sprites first, because that's the easier one. And organization-wise, I have 2 images in my folder that I'm going to use. And those images are in the same folder as my code is for both examples. So I have one big folder with all the code and all the assets. For the sprites, all I need is change pygame.surface with pygame.image.load, and then the name of the file, which in my case is ship.png. And then all we need is to comment out self.image.fill, and we would have our ship. So we run the code now. We can see a ship, and we haven't added the bullet yet, so we still see rectangles as bullets. And we can change this quite easily as well. All we need is for the bullet class, change this to image.load, and I called this one laser.png. And just as before, we have to comment out the image.fill, and now we have lasers. So now this is working perfectly fine. And here you have a very good idea that you have a class for the player, and this contains all the stuff for the player, and you have a class for the bullet, and this contains all of the bullet. And you can close them and just ignore them and just work with the actual code, which does make things quite a bit easier. And let me contrast all of this with the functional approach. The first thing we have to do here is import the images by themselves. And I'm going to call this ship_image. And just as before, it's pygame.image.load. And this is also ship.png. And then we also have to import the laser. And it's going to be laser and laser. And there we go. And now we have to display all of this. And I will start with the ship, which we are going to draw on the main game loop. So I'm going to comment out where we draw the rectangle. And instead, we're going to use screen.lit. And we need the image of the ship, so ship image. And then we can still use the main rectangle for the position. So this would get us the ship. If I run this now, we are getting the same result as before. We have our ship and we still have rectangles as bullets. But you probably already can tell that we have a ship in this position of the code, a ship here, and we get our rectangle here. So we have our ship all over the place, which isn't exactly ideal. Whereas in the sprite approach, it's all in one class, neatly tucked away, and it's all self-contained, which makes it much easier to work with. But okay, now let's work on the bullets. And the bullets happen all the way here, where we for now just draw rectangles. So I'm going to comment all of this out. And now what we need is to, again, split the images. And now I call this laser image. And we need the rectangle of our bullet. So if I run this works perfectly fine. So we basically have the same result in 2 different approaches. And neither takes all that much more writing. So our functional approach is 53 lines of code and our sprite approach is 58. But the lines of code don't really matter all that much. But the major advantage of the sprites is that you have 2 self-contained classes that basically control anything you have in your game. Whereas with the functional approach on the right side here, all the stuff is basically scattered around the code. And if you looked at this in half a year, it would be quite straightforward what you're doing. Whereas if you look at this one, you would have to work through this function quite a bit and try to understand what you are trying to do. And this is still a really simple game. If this became more complex, these sprites would become more and more powerful and it would still remain clear what they're doing. Whereas in the functional approach, you would create more and more complex functions that are more and more difficult to comprehend. So if you want to create more complex projects in Pygame, you have to rely on sprites. But yeah, that's it. Hope that was helpful and I'll see you around.